Alright, today we're going to talk about the triangle midsegment theorem. The objective is to use improved properties of triangle midsegments. Vocabulary word is midsegment of a triangle. Midsegment of a triangle is defined as a segment that joins the midpoints of two sides of the triangle. Every triangle has three midsegments, which form the midsegment of a triangle. Right, so this is what it would look like. X, Y, Y, Z, and ZX are all midsegments. And together they form the midsegment triangle. Now we're going to start looking at midsegments on a coordinate plane. The vertices of triangle XYZ are X at -1, 8, Y at 9, 2, and Z at 3, -4. Alright, so in order to look at the midsegments, we need to find the midpoints. We're going to let M and N be the midpoints of XZ and YZ. We want to show that segment MN is parallel to segment XY, and we want to show that the distance from M to N is equal to half the distance from X to Y. So the first thing we need to do is we need to find the midpoints, M and N. So we have to use the midpoint formula. We get that the midpoint of XZ is going to be at 1, 2. The midpoint of YZ is at 6, -1. Right, the next thing we have to do is we have to compare the slopes of segment MN and segment XY. So we use the slope formula. And we come out with the slope of MN at being at -3, 5. And the slope of XY is at -3, 5 also. Which means that segment MN is parallel to segment XY because the slopes are the same. Alright, now we want to compare the heights of segment MN and segment XY. In this case, we're referring to height meaning length. So we need to use the distance formula. And we get that the distance from M to N is equal to the square root of 34. And the distance from X to Y is 2 square roots of 34. Which does mean that MN is equal to half XY. And now I want you to try this next example on your own, following these 3 steps. So you got to find the midpoints, then you have to compare the slopes, and you want to find the length of the 2 segments. Alright, so here's this example. Pause the video, try to work it out, and we'll start with step 1 first. Alright, first step was to find the midpoint. Hopefully you got 1, 1 and 3, 4. Next thing I want you to do is to compare the slopes. So I'll give you a minute to find the slopes of MN and RS. Again, I'll pause the video while you work, or you pause the video. Okay, slopes are both 3 halves, which means segment MN is parallel to segment RS since the slopes are the same. Now I want you to compare the heights. Remember again, for this what we're doing, we're looking at the distance from M to N and the distance from R to S. So you'll have to use the distance formula. Pause the video so you can work this step out. Alright, so if you pause the video, you should have gotten the distance from M to N as a square root of 13. And for R to S, the distance comes out to 2 square roots of 13. So the length of segment MN is in fact half the length of segment RS. Alright, so moving on, we're going to look at now what actually happens with the midsegments, which you guys just proved in a sense for 2 examples. A midsegment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. So 2 things that happen. Since the slopes are the same, that means these 2 lines DE and AC are parallel. It also means that the distance from D to E is half the distance of A to C. So we call that the triangle midsegment theorem. Right, so now we're going to use that. We need to find the distance from B to D. Looking at the picture, the diagram, we notice that F, B, and D are all midpoints. So that means BD is a midsegment. By the midsegment theorem, BD is half the distance from A to E. And since AE is 17, half of 17 comes out to be 8.5. Okay, let's look at another one. We want to find the measure of angle CBD. Okay, so CBD is right up here. Looking again at the diagram, the midsegment theorem tells us that DF is going to be parallel to CA. Here's CA, DF. Right? And since the lines are parallel, we're going to use alternate interior angles, which means that CBD and BDF here, those are equal. So if measure of angle BDF is 26 degrees, that means the measure of angle CBD is also 26 degrees. Alright, so here is your example to try out. So pause the video and see if you can determine the distance from J to L. You want to find that length. Alright, so I got the distance from J to L to be 72 units. And like before, I went ahead and left out the steps, or put in the steps, so you can see how I got 72. Okay, here's another one for you to try. This time I want you to find the distance from P to M. So again, pause the video, work out the problem. Go ahead, pause the video. Did you pause it? Alright, so if you did pause it, did you get 48.5? Alright, I got one more for you to try out. This one I want you to find out the measure of angle MLK. MLK. Pause the video. Alright, because MP is the midsegment, it's going to be parallel to LK, which means that JMP and MLK are going to be corresponding angles. So that means it is also 102 degrees. Alright, next set of examples, example 3. In an A-frame support, the distance PQ is 46 inches. What's the length of the support segment ST if S and T are at the midpoints of the sides? Well, again, because of the midsegment theorem, we know that ST is half the length of PQ. So if PQ is 46, half of 46 comes out to be 23. Okay, so that means then that the length of the support ST is 23 inches. Alright, and this will conclude our notes for today on the triangle midsegment theorem. So now you may start your practice.